So my name is Natasha, and I'm a member of the IAU Junior Member Working Group. And I'm from Sydney University in Australia. And Ellie.
Hi, I'm Ellie Sansom, and I'm a researcher in Perth, WA at Curtin's Space Science and Technology Centre, and also on the committee of the Junior Member Working Group.
Cool. So welcome to the talk. So we are streaming it on Zoom as a webinar and also on YouTube as well. So we can see how the thing goes. So we've decided to organize this series to help the junior member community during the pandemic, for example, to have some interactions with colleagues and also like listen to some talks about career building and like very related things like how astronomy can help the community as a whole, and also to give some workshops on how to give good talks in Zoom and like these kind of avenues as well. So today we have a very exciting talk as well. So before we start off, I had to also advertise that our 3 years in the working group is coming into an end. So given the business meeting of the IAU is going to happen in August this year, we have opened up the elections to select a new working group for the IAU Junior Members Organizing Committee. So please, you should have got an email. So please have a look at the email. And if you're interested, then we strongly encourage you to think about it. It's a very good opportunity to interact with your colleagues in a global level and actually help form or shape the future of the IAU in some ways for the junior members. The deadline is on the June 25th. So have a look to your emails. There's also in our socials on Twitter as well, more information. And please, you can also email us if you have any questions about it. So today we're going to have about a 30-minute talk and then another 30 minutes for discussions. So if you have any questions, you can put it on the Q&A session in Zoom if you're joining via Zoom, or you can also ask in the live chat on YouTube as well. So without further ado, I think Ellie can introduce the speaker for today.
We have a fantastic speaker lined up today. We've got with us Dr. Natasha Hurley-Walker, who is an ARC Fellow and Senior Lecturer at Curtin University and part of the International Centre for Radio Astronomy Research. She uses radio telescopes to discover and understand astrophysical phenomena such as supernova remnants, radio galaxies and galaxy clusters. Her leadership of the Galactic and Extragalactic All-Sky MWA Gleam Survey resulted in the widest bandwidth, low-frequency radio survey ever produced, giving astronomers and the public a view of the sky in radio color, which is absolutely beautiful. So go and check it out if you Google it. She's currently working on a new sky survey, which will have twice the resolution and 10 times the sensitivity, enabling new astrophysics across a range of scientific studies. For her science work in gender equality and outreach activities, she's been named a WA Tall Poppy Scientist of the Year in 2017, an ABC Top 5 Scientist in 2018, and a Superstar of STEM in 2019-2020. And she's very keen for you to join her in the movement of sustainable astronomy at Astronomers for Planet Earth. And she'll be talking to us today about exploring the universe without costing the Earth. So take it away, Natasha.
Great, thanks a lot, Ellie. I'll just share my screen. All right. There we go. Hopefully everyone sees that okay. Yeah, so as Ellie covered, I'm a senior lecturer here at Curtin University in Perth, Australia. And this is more what I do for my day job is go and stand next to incredible low frequency radio telescopes and observe wonderful things about the universe. It's a really great job and of course involves a lot of travel and a lot of high carbon activities. And so more and more throughout my career, I've been thinking, oh, how do we balance this? How do we go about exploring the universe without costing the Earth? So I'll just show you that beautiful image of Gleam, just because it's so close to my heart. So this is the galactic center at visible wavelength, so you can see the light of hundreds of billions of stars and beautiful interstellar dust. And in radio waves, we get this gorgeous view of the synchrotron emission from the center of our galaxy and the entire galactic plane. caused by high energy cosmic rays spiraling around large magnetic fields. And you can see little supernova remnants dotting the insides of the plane, and blue patches, which indicate H2 regions. So it's a really stunning view. And of course, what you're looking at above and below the plane are billions of distant radio galaxies. So you're really seeing out into a kind of cosmic immensity. And so there have been times I see this image, or I'm out in the desert seeing something like this, and my heart stops. We just have this incredible, beautiful universe. And I want to know that we'll be around to keep exploring it. But of course, we face some big challenges in this century. So the biggest one and the most immediate threat is, of course, climate change. So the global temperatures have been rising since the industrial era began. And I'm actually a lucky xennial. When I was born in 1983, that's when we really departed the slow burn, and I have never experienced a year of average temperatures. I've only ever experienced every year being warmer than the last. And this is clearly not sustainable. So we all know the physics behind this, of course, as our industry puts CO2 and other CO2 equivalent gases like methane into the atmosphere. That traps heat as from the sun's radiation. And of course, that increases the global surface temperature. And to the layperson, you know, these small fractional, 0.1 degree here, 0.2 degrees here, they don't sound like very much. But I think as physicists, we can appreciate that that is an enormous amount of thermal energy that's being trapped. And there's no way of dissipating it. Once that insulating blanket has thickened, you can't get rid of that heat. You need to unthicken the blanket. Modeling from really fantastic scientists has shown that if we continue on our current trajectory, we're going to hit 4 or 5 degrees within this century. And already at 1 degree, we're seeing some pretty incredible and horrifying effects. And we believe our models and we believe our measurements. So I feel as physical scientists, we should definitely be accepting the message that climate scientists are bringing. Some of the effects of climate change are not just it's a bit hotter, it redistributes the precipitation patterns of the world. So if you look at the bottom left, there's 2 different models. One is a kind of maybe we'll be okay, sort of mild model, that's immediate emissions reversal. And you can still see there's quite a lot of extra drought across the Amazon, which is supposed to be a carbon sink, and Australia, where I live. And of course, on the bottom right, which is the kind of trajectory where we don't do anything, global rainfall patterns are completely and utterly changed. And of course, they become much spikier, which can lead to floods and mudslides and so forth. We also see sea level rise from both thermal expansion and the melting of ice sheets. I think 1,800 or 180 kilometer long iceberg just broke off the Antarctica a couple of days ago. So some of this is locked in and we're going to have to mitigate it, but we can still avoid some of the worst effects. The Arctic Sea ice at the bottom right there is an example of a tipping point where less and less ice coverage leads to a decreased albedo. And so you end up with more heating and a kind of horrible positive feedback loop. And that can lead to these kind of global tipping points where once they are gone, once something has changed irrevocably, it can't be put back. You can't just remove the CO2 and the Arctic sea ice goes back. So the same with the melting of the permafrost or the death of the coral reefs. There are things that are irreparable, irrevocable, irreversible. So we have a chance right now to get in before these things occur. And how does that happen? Well, the public gets sufficiently concerned. The school strikes for the future were doing an enormous growth across the planet. In late 2019, I was part of a group here in Perth. We were about 25,000 people of us on the streets. And, this is Perth. People like their cars here. So, these strikes were going very well. And then, of course, we had COVID. But that public pressure is there and that sentiment is there. And that does impact large organizations. So, for instance, the UN here has taking urgent action to combat climate change and its impacts as one of its sustainable development goals for the whole world. So that's kind of the UN, that's very high level. What you want is to see some real action from bigger organizations. And quite amazingly, last year, the International Monetary Fund, who are not really known for being lefty woke greenies, agreed that actually, yeah, we should really do something about climate change. And just a few weeks ago, the International Energy Agency, which has historically been known for propping up the fossil fuel industry, agreed that actually we should have no new fossil fuel projects by 2025, and then we should just start closing them down, which is a huge shift and, you know, an important one, but not the whole picture. Unfortunately, if you look at that, all those pledges and those targets from different organizations and from individual countries, it's just not quite enough. So we agreed in Paris to keep the world's temperature below 1.5 degrees, but our current pledges and targets are aggregated across the world, still lead us to a scenario of between 2 to 3 degrees. And if you actually look at the lower level policies, not just, oh, we would like to be net zero by 2030, like what they're actually doing, we're still going to widen this road, we're still going to build this freeway, so we're going to build this airport, then it's actually well on track for nearly 4 degrees of warming. And since we're already seeing effects at 1.2, we really don't want to go anywhere above any of these things above 1.5. Ideally, we'd like to go lower. I highly recommend you check out this site, by the way. You can do a country by country breakdown and see how your country is performing and where they're falling down. It's quite interesting. So why should you care? You're an astronomer. You didn't go into climate science. You didn't go into this stuff. It's depressing. It's exhausting, and you know, it's quite anxiety inducing. You just want to do your science. You've only got so much time in the day. Well, you know, why should you have to take on saving the world? Well, I would say that simple answer is because you want to do your science. Okay, this stuff is real. It's happening, like it or not. We are all ECR, MCRs. We can't use the excuse of it'll all be happening after I retire, and it's not my generation's fight. No, it is our generation's fight. At the very least, consider these, this should come with a trigger warning, by the way, for astronomers, consider the direct impact on the observatories that you're planning to use. This is Siding Spring Observatory in 2013, where an enormous bushfire ripped through. And yeah, it's hard to watch for me, both the forests, but also our beautiful scientific instruments going up in flames. And these sort of events are just going to become more and more common. And regardless of where you are in the world, in the same way that the pandemic has affected observing, climate change will also affect your observing in supply shortages, in lack of access, in direct, you know, destruction like this. So we do need to be concerned. We should also be concerned because it is morally correct. We are not saints going about our business, having very little impact on the world. The global footprint per year of tons of carbon dioxide per year for the average person is about 7. I live in a developed country. We are really dreadful here. You know, it's 5 times as high. But astronomers just average across the world are even worse again. This paper I'll come back to, Adam Stevens's paper on why we should reduce carbon emissions and how, is really excellent, and I'll refer to it later. So we have a moral duty because we're already using more than our fair share. And you also think we have a duty for our own survival, because if our sort of our industry is not net zero within 2030 or within 2050, it's not going to be around. Every other sector of the economy, people are going to be looking to cut and to make net zero. So if astronomy isn't, then we will be cut. So we should get ahead of the game and think, no, hang on a minute, how can we do this sustainably so that when the carbon taxes come in, when the pricing comes in, and when people say, we've got to cut things that have very large footprints, we're not just up against the wall. So net zero by 2050, I'd say, let's just do it now. And I'll show how we can. Other reasons, we should be honest about the possibilities of human colonization of space. You know, I love the pictures coming from Mars. I love exploring the solar system. I love looking at distant exoplanet discoveries. It's wonderful, but let's not kid ourselves that this is something that feasibly could take humans. Humans need biospheres, humans need support systems. Even the people in the ISS have to be refueled constantly with shipments from the Earth. So talk of Mars colonies is absurd. I'd like to see somebody try and colonize the center of the Sahara, where at least you have a magnetic field and oxygen in the atmosphere before you try and colonize Mars. Another reason is that if you are writing your articles, you might like the idea that they'll actually be read. It's a little sad to be trying to work on exploring the universe if you're constantly thinking, no one's going to be reading this in 10 years' time because we'll all be fighting for our lives. So if you could put a little bit of your time aside and know that you're doing your best and have that hope that there will be someone to read your, well, maybe not grant proposal, but your paper, then it makes it that much more worth writing. And finally, we don't want to be that guy in the first picture who's cut down all the trees so that you can have a nice view. How will that look to the public in a few years' time if we're still swanning around on international travel and using diesel to power our observatories? Public support is not going to be there for us. Public support is there for people who are fighting disasters, not creating them. So we want to have pride in our community. We want to say, I'm proud to be an astronomer and to be giving people that perspective and to be helping, not harming. This is my actual and finally. You'll also find if you care about this stuff at all, if you haven't managed to just completely deny the existence and just say, nope, this is just not my problem, then you'll probably have some sort of underlying anxiety about it. And if you're not doing anything at all, if you're just, you know, going to work, and it'll be lingering, it'll be bothering you, because that's how human emotions work. Anxiety is telling you that there is something wrong with your situation, and then we express that in feelings of anger or grief, and then those things are motivators to action. If you take action, the anger and the grief dissipate, and the anxiety dissipates as well. So you can, if you take an action, then you will feel better. So it's a kind of a selfish reason, but it's true. Now, I haven't really answered why. Well, I've answered like why you should feel the survival of the field and so forth, but why you specifically? You're just like, hey, I'm just trying to do my PhD, man. We are actually very privileged people in terms of our education and the kind of influence we have over society. If you're listening to this talk, you probably have at least half a degree in astrophysics from a university somewhere, and that makes you very, very well educated as far as the global population goes in terms of critical thinking, understanding of statistics, physics, and so forth. And you are surprisingly influential. Journalists respect us, the public respect us. This right-hand plot shows a survey done in 2016 about who is believed and respected in the US. And unsurprisingly, elected officials are right at the bottom of the pile. I wouldn't say anything about the military. I think that might be an American thing, but we're nearly top of the pack as scientists. Now, additionally, we're not climate scientists, we're physical scientists. We understand atmospheric physics, but we have nothing to gain by talking about climate change. We have everything to lose. If it were made up, the best thing we could do is say, that's a hoax, please give us some funding. And if it's real, we also have nothing to gain by talking about it other than the survival of the species, because we just want to say, oh, I'm just doing science, I'm an impartial person. So when we speak up and when we say, no, this is an existential threat, it has a lot of weight. We're also awesome. The public love us. We show them cool pictures of amazing things. And so you can show people a cool picture of an amazing thing and then say, I also have some other knowledge to impart. So this brings me on to what we can actually do. You're motivated, you are, agree that there's something that needs to be done, but what can actually be done? Well, I've kind of separated this into three sort of buckets. Other people might have their own breakdown, but as far as I can see it, this is kind of how it stands for me. So first off, you can just change everything about your own life, right? Apparently you're causing all the carbon emissions in the world, and so you're going to be the one to fix it. So I'm just using myself as an example here because, it's an easy one. I know everything. about me. So things I do, right? Like I ride a bike. I ride a bike everywhere. You'll see me on my bike. You'll see me on my e-bike. I have about 20 bikes across the family. And it's great, right? But I would do that anyway because cycling is cheap and healthy and fun. And I hate driving and parking. So the tiny amount of carbon that I'm saving by not driving my car is really not going to help all that much. I don't buy things. I just buy nothing. I recycle. I go to protest marches. But these things are all very, very, very low impact. You know, even if I could convince everybody to adopt my lifestyle, the big mining projects will still be exporting resources overseas. But this is kind of rearranging the deck chair stuff. You should do it. It's necessary because I'll show later we don't have a lot of choice about these things in the future. But I'm not going to say that you just get green energy in your home and everything will be fine. So that's not super effective. Well, there's only one of you. What if you reach a lot of people? And I mentioned before, astronomers have a lot of sway with the public. And you might think, oh, well, I'm not an expert on climate change, but really, it's not that complicated. I managed to explain it a little bit earlier. We, as physicists, are more than capable of explaining the physics of climate change. And we have also very cool things like Venus to draw on. We can show other planets rather than focusing on Earth, and then kind of come back to Earth at the end. And so then you've led people on this astronomy journey, and then you say, well, actually, this all applies to Earth as well. You can talk about exoplanets and how close they are to their stars and how far they are away. One thing I really don't like about the messaging around exoplanets sometimes is this use of the phrase potentially habitable. I don't think that's fair, like magically habitable maybe, if you happen to be there. But these things are tens of light years away. So they're completely inaccessible. You'd need generation ships traveling for tens of thousands of years. It's way beyond our current technology. So consider your messaging around habitable exoplanets. It's, I think, a little bit misleading for the public to use that word, because there really is no planet B. You can also talk about how climate change may actually be affecting your observations. So I can't find the reference for this poster on the left, but these are observations at an observatory where they actually, across this poor student's thesis, the CO2 level measurably changed while he was trying to examine a distant source. And that's kind of horrifying. You can literally see climate change every day when you go out to take your observations. And Cantalube et al. Also wrote this quite nice synthesis paper of how in future this could be quite serious. So this plot on the right shows you get more blurring or reduced seeing of optical sources because of the increased heat and turbulence in the atmosphere. And these things are all direct observable effects. There's no agenda, you can go out and measure them, and we don't want them. And I think finally, the most important thing that astronomers bring is that sense of cosmic perspective. I was talking about the beginning when I look at Gleam, when I look at that whole picture of the universe laid out before me, it just makes me want to preserve our knowledge of it. We are, as far as we know, the only part of the universe that can know things about the universe. And we are a tiny mote of dust, as Carl Sagan said, floating in a sunbeam. So being able to communicate that perspective and how precious and unique Earth is probably the most important thing that astronomers can do. So that was outreach. Now that's something you can incorporate in your own talks, but what about changing astronomy? How can we fix astronomy? I've said we have a large footprint. Well, my take on this is that your individual actions in switching to solar power and riding a bike are not really going to affect things. We need collective action. All of us operate under charters, constitutions, codes of conduct, guidelines. We apply for funding and it has rules associated with it. If we choose, say, to not fly to an international conference, that's very well for you. You've saved your carbon, somebody else gets that slot on the airline. If the conference organizers won't let you dial into the meeting, which was very, very, very common pre-COVID, you've just cost yourself that kind of exposure and networking opportunity and possibly your future career. So you individually taking that action is no good. Whereas if you get a bunch of astronomers to agree with you and you lobby your institute or the global national institution for your country to say, all conferences should allow people to dial in and not discriminate against virtual participants. That's a huge effect, right? Now you can say, I'm not going to take that flight. And do you know what? Lots of other people are not going to take that flight. And nobody's going to suffer because of the damage to their career. So this collective action can be incredibly powerful. We've been engaging in this now in Australia for about a year. We have a sustainability committee as part of the Astronomical Society of Australia. Thamia's a member as well. We have convinced our national body to make a statement agreeing that climate change is a real and present and existential danger to the species. And we, as astronomers in Australia, should commit to certain actions, which I will cover here. So it does work. And if everybody does this, it can be quite powerful. So coming back to Adam's paper about where our carbon footprint actually sits, I'm just going to go through Australia as kind of like a case study. But those of you who are listening might want to consider what's true in your life, in your national circumstances. So in Australia, we've seen a massive growth of supercomputing. I'm sure this is probably true worldwide, where people are using powerful supercomputers to do simulations and process big observations. Flights for conferences are a big thing here because we don't have a rail network that connects all major cities because they're too far apart. And observatories are usually in remote areas and they take energy to run. So I'll cover these in kind of a random order, but observatories are more and more moving toward a remote model. And maybe you use an observatory where you used to fly to it, but now you don't because COVID. So I think that this is kind of happening because of the pandemic. All of you're going to fly over to Chile for 3 nights. That's all going to change anyway, which is a great thing. Of course, those observatories still, that cuts the flight cost going to the observatory, but the observatory is still using power. And so, maybe you know somebody, maybe you have a way of writing a letter or generating some communal action to ask for more renewables for observatories. In Australia, we're blessed with enormous amounts of sunshine, so it's just economically sensible, but it does depend on your local circumstances. Supercomputing is a bit of a harder nut to crack because it's just so much energy, right? What we end up finding, and sorry about the messy slide, it's more just press releases than anything you have to read. What we find is that the supercomputers just run on grid electricity. So in your state, if your state uses renewables, then your supercomputer is using renewables. So the Australian Capital Territory is 100% renewable here in Australia. So all our supercomputing that's done in the ACT is 100% renewable. Well, yeah, that means you just need to lobby a little bit higher. So we're talking state government here. And also it's possible that you can still make a difference. So for instance, Swinburne, which is an individual university, they made an agreement with their state power company where they would buy 100% renewable electricity from the power company. So that was done, because the director really believed that we have a problem with climate change. So if any directors of supercomputing or institutes are listening, this is a choice that you might be able to make, and that puts pressure and sets a good example. Now, conferences is the big one. So conferences, we've obviously just sat through a year and a half now of Zoom conferences, and they definitely fulfill a really important role in sharing information. This is an example of the American Society of Tropical Medical Medicine and Hygiene international conference. So they measured the CO2 of everybody who flew to the conference. And this is just what we were doing, pre-COVID, just this cash, get on a flight and fly halfway across the world to be there for a few days and one talk. That obviously generates an enormous amount of CO2. And if you switch to like a hub model where there's multiple conference venues and people are only going to that local one, then you approximately halve, maybe just slightly above, on average, your CO2 emissions. So, it's okay. You don't solve the time zone issue with this. You end up networking with people only from your own country. So it's a bit of a challenge, and you maybe this isn't the best solution. What I think we've found, even with this series right now, is that we're actually learning how to use virtual tools and creating something that might be even more accessible than physical conferences, and trying to replicate some of that important networking and communication that you get, the spontaneous chats that make conferences so great. So I was part of the Future of Meetings Symposium. And if you follow either of these links, we have a whole write-up of thoughts about how you can make a great virtual meeting. And of course, it's practically carbon-free. You can offset it with just a few trees planted. So this year for the ASA, for the Australian meeting, we have a hub model. And because of our population density shown at the bottom right, that means there's no flights really, because everybody lives so close to a major city. Anyone doing professional astronomy anyway. So it's going to, sorry for Tasmania, Adelaide, Darwin, I see you. I'm in Perth, I see you. We have got 5 hubs, it could have been more, time constraints. So this should be a dramatic reduction in the carbon emissions for this year's ASA, and let's try and make it a good one. So that's national collective action. It does work, and I think that's a really good path forward for anybody looking to reduce the impact of that they're making on the planet. But it doesn't scale up to an international level very easily. We can't really lobby the United Nations and say, hey, you should adjust the funding rules for astronomers. They've got no power. So what you need instead is a collective that spans international borders. And so that is the goal of Astronomers for Planet Earth. So we're a grassroots movement. There are 500 or so of us now. And we all agree that there is no planet B and we need to take steps to make astronomy carbon neutral. Also, I would add that you should join us, yes, but also on the page, there's also a resources link, and we have a Slack where people share tips for giving outreach talks about climate change. So if you're feeling like unprepared, but you want to do something, join A4E, and then you can get access to those resources, and then you're not like frantically Googling things yourself. We have this fantastic open letter, which has been signed by over 2,000 people now, professional astronomers, astrophysicists, science communicators all across the world. And that is now getting endorsed by institutions. So we are having that effect of international collective action affecting the institutions, which will then affect the circumstances in which we operate. So this is great, and I encourage you to sign and share the letter. So to recap, now, I know I'm 1 minute away from finishing, but I do have 5 more minutes after this. So I would like to do that if that's okay. But I'll just recap where we are in this kind of like mid part of the talk. Climate crisis is real and urgent. You do have good reasons for wanting to avert it. You can make a difference with not that much of your time. So sign the open letter, join Astronomers for Planet Earth, think about how you do outreach, and how can you affect your own country. So I'm now going to move on to the kind of, I like this, the fun part of the talk, although it is kind of maybe bleak. So climate change is a really, really difficult thing that we need to deal with, and maybe together we can fight it. But it is also a symptom of what our entire sort of structure is doing, our sort of global endeavor as a human species. And we, as physical scientists, do have some tools in our pocket where we can have a think about, even if we fix climate change, what's going to happen next? What are the more fundamental things that we need to change? So I think you probably imagine, if anyone who knows me will know I start banging on about this, but economic growth is kind of seen as a fundamental linchpin of our society. And if you look at, say, the US GDP, which is a classic measure of economic growth, it's been going up exponentially. This is a log plot since the Industrial Revolution. And we love economic growth because every time the economy starts to go down a little bit, we all wonder if our funding is going to get cut, right? We want the funding to go up, not down or disappear. So, of course it helps society, but it also helps astronomers. The problem with that is that you need energy to fund economic growth. Energy goes into moving things around, making things, disposing of the waste. It is kind of fundamental to economic growth. And if you look at the difference between the GDP and the energy use, they're 100% correlated. So if you say, okay, well, that latest downturn, that's probably export of manufacturing to China, but let's just assume that's a sustainable trajectory for economic growth and energy use. That's about 2.3% per year. Now, most people would agree that's a great growth rate for an economy. Whenever I give this talk to the public and I say, hey, what do you think is a sensible growth rate for an economy? People say 2%. They love that number for some reason. So this is great. Okay, 2.3%. The problem is we are all masters of exponentials and growth. So that means that every 100 years we need to multiply our energy use by a factor of 10, which maybe that seemed reasonable in 1700, but it doesn't really seem reasonable now. So if you think we're not going to use fossil fuels, we're going to use renewables to just power this. We need to grow at 2.3%, otherwise our funding is going to get cut. Let's use renewable energy. So in about 300 years, you need to have covered, e.g., the Americas in solar panels, or the equivalent area of the ocean in wind farms, or etc. It's not a small undertaking, and 300 years seems like it's quite far away, but it's still something we would have to be working toward as like a global plan to do this. That's pretty epic. Okay, so fine, we got there, 20% of the land. The problem is that if you keep growing at 2.3%, that buys you almost no time. And within less than 100 years, you have to cover the entire land surface of the Earth in solar panels. And within another, 50 years, you have to cover the entire Earth. So that's not to say that this is going to happen. Even that 20% figure is stupid. This is pointing out that, like, fundamentally, we cannot get the energy required to grow our economy at the rates that our entire system is built on assuming that we will grow to. Now, just for fun, you can also keep extrapolating this and say you've got 1,000 years to build a Dyson sphere, and then you've got another 1,000 years to colonize the galaxy. And I think we'll all agree that that is unrealistic. Now, not worrying about the space cadet stuff, we just go down to the bottom left and we have a look here. We say, okay, fine, let's do fusion or something, right? We're not going to do solar because it didn't work. We have to use too much land area. Let's come up with a new technology like fusion. The problem is that all energy produces heat. When we use up energy, it just is lost as bad waste heat. So that's a negligible problem at the moment. The heat that we're experiencing is from the CO2 trapping the sun's light. But if you keep on growing at 2.3% and you use even magical fusion Iron Man technology, if it generates heat, then that heat is going to go into the Earth's atmosphere, Earth's oceans, etc. And so again, you start to hit a sort of 350 years, you're at 37 degrees of climate change, right? So it becomes completely impossible. Again, not to say that this is going to happen. I'm just pointing out that physics puts a limit on our ambitions. And I put the link at the bottom for this excellent blog, which kind of inspired me to start thinking about this about 10 years ago. That Professor Tom Murphy has now, here we go, written a textbook called Energy and Human Ambitions, where he goes into this in a lot of detail, and I really highly recommend you check it out. There's a link at the end. Now, the last thing on this is that while a lot of economists say, yeah, that's fine, that's because at the moment our economy is coupled to energy use. That doesn't have to be the case going forward. Look at our magic economy now. It's all services and finance, and somehow we're not doing any manufacturing, and yet we're still fine. Okay, one, we exported all that manufacturing. Two, you can't extrapolate that forever. So if you want the economy to keep growing, which in the right-hand figure is this red line growing at 2.3%, just expanding upward at a straight line in the logarithmic graph. And you also have like an actual physical limit on your planet of like what can be done physically, which is the blue line also kind of going up exponentially and then leveling off. When the blue line levels off, you're using 100% of your planet, and yet you need the red line to keep going up. And so what that means is you get this purple line, which is shown by the second axis, where it's the percentage of the economy that it is non-physical. So it's not moving things around or making things or consuming them in any way. It's just poetry competitions online, and you don't go on a cruise ship, you put a VR goggles on and you see as if you were on the cruise ship. And so these numbers are all arguable, but it quickly becomes ridiculous that you've got to keep growing the economy, but you can only do it by better virtual cruise ship experiences. And 100% of your economy just becomes people trading, memes, well, NFTs, eh? But yeah, it becomes unphysical very quickly. So that's decoupling, and that's not a solution either. Neither are efficiency gains. I don't have time to talk about that at the moment. So in a public talk, I usually leave it here, like what we're adapted for as sort of social animals is, actual immediate peril that is life-threatening and is going to kill us right now. And what we're facing now are these very big abstract threats. People are drawing graphs at me. What's happening? I would argue, with apologies to the comic artists, that we here, listening and reading this stuff, should react appropriately. We should understand that these are not just abstract graphs that you can just ignore. They relate to real physical quantities on our planet, and we should use our training to kind of critically analyze that and then think about what we do next. What we do next, of course, is a much bigger problem than tackling climate change. And I don't have the easy answers in this 30-minute presentation, but I would probably suggest that thinking about how we structure our society such that we're accomplishing the goals we want to accomplish as a human species, rather than abrogating all responsibility to financial algorithms of infinite growth, would be a good way forward. So I don't know where this journey will take me in the future, but I hope that at the moment I'm able to inspire a few more people to think about this. And next time you hear a politician banging on about jobs and growth, that you take that with a pinch of salt and think, how sustainable is this in the long term? Now, of course, we could bang on about all this. Maybe it's not a problem. If you would like to hear more people banging on about this, we are running a special session at the European Astronomy Society meeting this year. And we have an incredible range of speakers lined up. Climate scientists, people who are astronomers changing their institutions for the better, experts on virtual meetings. It's going to be a lot of fun, and registration is still open. And because of COVID, it's a virtual conference, so accessible to anyone in the world, even Australians, if you don't mind staying up a bit late. So I will leave it there. I've got a whole range of references of things that I have read that have helped me. The top are kind of like, more like gritty nonfiction stuff, but down to the bottom, especially the Ministry for the Future, I put down a few books that I've really found help as well, give that emotional perspective and kind of connect it to our lives. So I hope that helps. I hope you enjoyed this, bleak as the topic is, and I'm very happy to take discussions and questions.
Thank you so much, Natasha. That was really cool. I have so many questions, but I'll let Temin take it away with the first one. And guys, if you would like to, if you're listening in on Zoom, put your questions in the Q&A session there, or if you are on YouTube, please just send a question or a comment, and we'll try and answer them all in the rest of the time that we've got.
Cool, thank you. So yeah, it was a great talk, Natasha, thanks. So I think before we dwell into the questions regarding the science and the talk, like about the scientific aspect of the things, my first question is more towards the ECRs, because this is the aspect that you covered in the very beginning, saying about virtual conferences and like hub models, etc., especially what the ESA is doing this year. So this question has come up with multiple ECR communities on how we can balance the sustainability initiatives with like progression for career development for ECRs. So I just want to know what your thoughts on that is.
Yeah, I think we have to reevaluate, what are we doing with conferences? What is the point of a conference? And then think about the technologies that we need to build toward those goals and use them, rather than trying to replicate a physical conference. So I have not yet been chair of an organizing committee of a virtual conference, although I've been on lots of SOCs and LOCs. So I haven't yet had a chance to put my money where my mouth is, as it were. But a lot of us, when doing an online conference, we structure it very traditionally. with, you know, at worst, like an 8-hour day with a 1-hour gap of just back-to-back Zoom calls. And I think this is not meeting our actual goals. So our goals are probably make sure ECRs get some exposure for their really cool work, networking, getting new results out there, important discussions where you come up with new ideas and new directions for the field, right? So those are some of our goals. And we could do better, right? We could make sure that ECRs get the live talks and professors get the pre-records, right? Have the professors on a Zoom, on a YouTube list, and people can go and check out their work. They're going to anyway because they're big names, but ECRs get the live talks. You could have a kind of an online system where people register that they liked your talk and they would like to talk to you, and have a dynamically scheduled discussion time and prioritize ECRs in that process. You can have networking that isn't just dump people in a Zoom room and expect them to just like magically form connections. You can ask people about their interests ahead of time, ask people what their goals are, ask people who are willing to mentor. We have the technology to do this, but we never leave ourselves enough time. We're still treating conference organizing, especially virtual conference organizing, like it's just a stopgap before we return to flying all over the planet. And I think that might work. Maybe we're going to go back to flying all over the planet for 5 years or 10 years until the next pandemic or until the big carbon prices come in. And then we're going to have to reassess. So I say, let's reassess now and come up with sensible solutions. So here in Australia, the ASA is heading up a group about how to develop good virtual conferences that meet the goals of, you know, what we actually want to do, not just replicate physical conferences. So I've joined that group, and I hope anyone else who's Australian who's interested joins that as well.
That's cool. Actually, it leads me into the one of my next questions was, well, obviously with COVID, we've had this huge shift away from travel and towards the virtual conferences. And already over the last year, the technology has developed incredibly with like the virtual gathering meetings and things like that. And just, I don't know, is there a way that you reckon we can try and keep that momentum up rather than losing that and going back to, oh, well, all right, it's over now, we can go back to flying? And
yeah,
whether
I think
like how much that's on individuals versus like the organizations or organizers of the conferences.
Yeah, so I think it's important actually that we find out how this has affected the community, because, you know, I'm very pro. I think it's I think we should do virtual meetings. I think it's just physically going to be necessary going forward. But we should talk to ECRs and PhDs and people with caring responsibilities, and, you know, people who might not have been able to access these conferences. I know that registrations for virtual conferences are now, you know, you get thousands of people. You get 3 or 4 times as many as you would have if it were physically located. So for the Global South as well, this is a huge equity issue, and is allowing access for people who would maybe normally only be able to attend a conference every 5 years. They can now go constantly. So I think we should ask people what's their experience. And, you know, I think that there's probably a huge silent, or, you know, marginalized group out there who aren't on boards or institute directors, or, you know, who really like the current model and would like us to put our efforts into improving that, but perhaps we don't know. So yeah, some way of asking people would be interesting. But I'm also keen not to like completely derail the careers of PhDs and ECRs if they're feeling that the current model isn't working, or we need to change the model. So I'm sorry I don't have like a straightforward answer, but I think crowdsourcing that answer is more powerful than me coming up with it.
Yeah, definitely, I think, because I think at least in part of Australia, like what I found out is that the time difference, especially for Europe and US conferences, have been a killer, right? So maybe we need to rethink the whole model of how these things are worked out, so it's more friendly for people with caring responsibilities and such as well. Yeah, so before we go to the next question, Manojdeep has asked whether the slides are available publicly. Sure. I know the talk is in YouTube, it will be streamed in. Yeah.
Yeah, I can totally make these available. I'll give them to you guys. You can find a way to make them available, or I can stick them on my website at the bottom left.
Cool, great. So the next question that we had was about how to engage with like climate skeptical viewpoints in the community, especially with at least in Australia with politicians or maybe in the general public. So how can we like go on about astronomers and try to push more green initiatives in the local and state governments and even the federal level, right? Like I think you touched it a little bit, but I was wondering whether you can like expand a little bit on what are the drawbacks that you get like when you try to talk to politicians.
Sure. Yeah, no, I can try. Now, I'm not a social scientist or a psychologist, and I'm very aware of the Dunning-Kruger effect here. So I'm only talking about things that I've read. This is not research that I've done. But from what I understand, emotion really is our primary motivator. It's actually why we do things. We think we're acting logically, but often we're just acting to satisfy an emotional need. So if you are talking to somebody who doesn't believe the facts, you might want to have a think about how it appears to them. You've got some elitist ivory tower person who isn't connected to farms, isn't connected to real work, telling them how to change their life. Well, that's they're really not going to listen to you. But if you reframe it, do they have kids? Do they have grandkids? Were they affected by the bushfires? Do they have friends, who live anywhere snowy, who have seen the actual changes? Do they fish? Are they, have they noticed the reduction in fish, the changing of the patterns of the species? Have a think about what connects with them and that is in their life and in their context, and then think about the emotions that motivate there. The worry about children is probably the most universal one that connects most people. And you're probably just going to have to not change that many people's minds. Sometimes it's better to just use your energy somewhere else rather than winding people up. If you come back very aggressively, you're not going to change each other's minds. You're just going to upset people. And so sometimes it's not worth it. But if you talk to somebody who knows that person and then you change their mind or you give them some more facts, they might change the other person's mind because they have a connection already. And so we're not a logical species. You have to work indirectly. As for politicians, you have to think about, well, how does this look for them in terms of their career? They've got to worry about being elected. It's a bit like us. We've got to worry about what comes up on the grant proposal, right? I get this paper out so the grant proposal looks good. The politician has to take some good action so that they get elected. And so thinking about like Matt Keane, for instance, the New South Wales energy minister, he said, in contrast to the federal politics, I think climate change is real, but who cares? I don't care. I'm not a woke left greenie. What we do care about is the economy, and we need to make a renewable energy transition or we're going to be left behind. And that got this entire segment of the population on board. Now, concerns about economic growth aside, reducing climate change is the most important thing we can do right now. So again, if you're talking to a politician, well, think about international standing, think about security issues, resilience, just the economy going forward, carbon pricing, all of these things like coming from an international scale. This talks about carbon taxes on exports. So there's ways that you can address things both emotionally and logically, and also just be prepared to walk away.
That's great advice. I've a bit more of a specific question, I guess, with that, you've shown how supercomputing is such a huge energy use of astronomers. And I was just wondering on your thoughts of trying to balance, I guess, personal time the time efficiency with kind of computing time efficiency. So, and I know, I don't know if that kind of makes sense, but should we be trying to put more effort into making code run efficiently? So I know that I can run something that will work on the supercomputer and I can set it going, and it might take a couple of thousand core hours, but if I'd spent 2 more weeks working on the code to make it more efficient, maybe I could half that. So what do you reckon, is there a good balance kind of in there somewhere of personal time versus compute time, which actually translates into energy?
I think other people have done more exhaustive analyses, and I didn't have time to talk about efficiency in my talk, but as you say, efficiency buys you factors below 10. It buys you 2 or 3. So yeah, if it's going to take you personally an enormous amount of time, it may not be worth it. The other thing that often we talk about with efficiency is like this comes down to CPU time and system, like human waiting time, is people will run non-parallelized jobs on supercomputers. So they'll have a node that has 20 cores and they'll run something that's using 1 core. And they're just like, oh, I just don't have time to use all 20 cores. It would take more effort. Now that's terrible from the efficiency of the supercomputing queue and people who want to use the system and are like, why is this job taking so long? But in terms of energy, it doesn't matter, right? The other cores are just sitting there idle. They're not burning energy. They're not producing heat. They're not making CO2 at the power plant. So in that, it depends how much efficiency you can really get. Like the back ends of the codes that we're using, like Python just sits on top of a bunch of C libraries. It's usually really, really efficient. So unless you've made some really terribly stupid mistake about how you're handling things, like maybe memory is a big one where you can tie things up infinitely. You're probably not going to get that much from efficiency. That said, it's important to do. And if you've got like a supercomputing center where they've got trained people who can have a look at your code, do it. You know, it's only going to take a small amount of your time. And at least here in our group, and you've been to a couple, we run this this collective group called Standard Error, where we all talk about computing issues, and you're just constantly picking up tips about how to do things better. So I think it's important, but it's not going to save the world.
But yeah, I think like taking advantage of like the people who work on supercomputing facilities is the best thing to do, right? Even ADAX in Australia is kind of doing that. If you have a code and problem, they will help you optimize this thing. I think given the time, this might be our last question. So maybe it's more like an open question, because we know the IAU is the more global view of the international astronomers. So what do you think the IAU should do to address the sustainability initiatives in where because we see like a grassroots movement from like astronomers of planet Earth and stuff, but IAU has been a little bit more, has not been actively engaging yet. So what is your thoughts on what the IAU should do and where we should go with that?
Sure. I would love to see the IAU endorse the Astronomers for Planet Earth open letter. So for them to put a statement agreeing that there really is no planet B and we do need to address the climate crisis, and we have the means and the motivation to do so. I think that would be a very strong message. The IAU is also responsible for lots of conferences every year, and to see them make a strong move towards them being virtual first, so saying we would prioritize virtual participants. If there's a physical location where the LOC are, delightful if people want to meet up for some coffee, but can we make these virtual experiences really excellent and focus some energy on doing that? That would be really good to see. And of course, you know, if the IAU are saying things like this has a knockdown, a trickle-down effect on all of the other astronomical institutes worldwide. So it's probably one of the most influential organizations, and I would really like to see a strong commitment. I think it's just a very slow ship to turn. A4E has approached different parts of the IAU, and they've all kind of said, we need to go right to the top with this. So yeah, I really hope to see that in the next couple of years, to be honest. We have a really great moment right now where we haven't resumed international travel and we haven't resumed people flying to observatories, and we are developing the right technologies to still continue our science. So why not capitalize on it?
Awesome. Yeah. So hopefully we can try to pursue this further with the IAU then. So yeah, thanks for the great talk. It was like so amazing, and like so much information out of it. And for people, it's also on YouTube as well. So you can go back and listen and even copy the links as well. What we'll probably do is once Natasha sends the slides, we can put the link on the YouTube comment section so people can get that easily from there. And so we have advertised our next series of talks, the last set, I think, for us. So the next one will be on the June 10th at 8 a.m. UTC. And we will talk about, it'll be more like a workshop done by Yellow Research. on how to sell research idea to the reviewers. So I think that will be really interesting for the ECRs on when you try to write your own research proposals for grants and stuff like that. I think that'll cover like how to address these things that you think are important and put it in the context of reviewers. So to hope to see you all there. Our socials have all the information on how to join and get the links and register, etc. So thanks again for Natasha and for everyone for joining us today.
Thank you all.
Thank you, everyone.